Hey guys, so we're going to keep moving along in chapter 5, moving on to lesson 5.4. Let me present my screen so we can get started. Okay, so far in this chapter, we've worked with radical expressions, expressions with rational exponents, as fractional exponents. Now we're going to continue to work with radicals, but we're going to look at some radical equations, okay? So the first vocabulary term a radical equation is simply an equation that contains a radical with variables underneath the radical. All right, so an equation with a radical that has a variable in the radicand. That's underneath the radical, okay? Extraneous solutions are solutions that are not solutions of the original equation. So sometimes you'll get solutions, but in fact, they don't actually work. They're false solutions. So it's going to be important to think about your answers and to check, kind of plug them back in, whether you actually write it down and plug it in or just mentally do a check and plug in the value that you saw for X to make sure it actually does work. Okay. So next, solving radical equations. So we have some steps. They have 3 steps written here. It says isolate the radical on one side of the equation if necessary. Then step 2 is raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So that means if the radical is like the square root, you're going to square both sides. If it's a cube root, you're going to take the cube of both sides. If it's a fourth root radical, you're going to raise both sides to the 4th power. All right. And then whatever equation is left, whether it's linear, quadratic, or some other polynomial equation, you're going to solve that equation using topics learned in previous chapters. So if it's a linear equation, we know how to solve linear equations from Algebra 1. If it's quadratic, we try to factor. If it can't be factored, generally I jump right into quadratic formula. And if it's a polynomial equation, we learned this year how to work with polynomial equations. You may be able to do synthetic division in order to factor it. It kind of depends on the problem from there. All right. Otherwise, you're going to use the rational roots theorem. All right. So I'm going to jump into the problem set. So this is a 2-day lesson. Today, I'm going to work on the odds. And then the next lesson, I'll come back through and work on the even. So you get lots of practice. All right. So today, we're just focusing on the odds. Okay. So the first step of solving was to isolate the radical. Well, this radical is already isolated. There's nothing outside of the radical on the left-hand side of the equation. So the second step was to raise both sides to whatever power is necessary to get rid of the radical. Since this is a square root, I'm going to square both sides. All right, the square root and the square undo each other. So you're left with 1 minus x equals 7 squared. You can go ahead and square that 7. So 1 minus x equals 49. I'm going to subtract 1 from both sides. So negative x equals, when I subtract 1, I have 48. Divide both sides by a negative, and you're left with x equals negative 48. All right, now to check, you just have to make sure that if you plug that back into the original equation, that's not what I meant to do. Let me write the answer down again. X equals negative 48. X equals negative 48. If you plug the negative 48 back in, does it work? Okay, and if I plug in negative 48, I have a negative that turns into a positive. So it's 1 plus 48. That's going to be 49. And the square root of 49 is 7, which is what's on the other side of that equation. So it does work. Okay. All right. Number 3. So for number 3, the first step is to isolate the radical. So using inverse operations, just like I would any equation, I'm going to subtract 6 to start. So I have 1/4 times the 4th root of 2x equals 4. Then I have to multiply both sides of the equation by the reciprocal of this fraction. So multiply both sides by 4. So I'm left with the fourth root of 2x equals 16. Now I'm going to raise both sides to whatever power is necessary to get rid of the radical. So since it is a fourth root, I'm going to raise both sides to the fourth. The fourth root simplifies with the fourth. I'm going to write over here. So this is not problem 4 that I'm working on. So I have 2x equals 16 raised to the fourth is 65,536. And finally, divide both sides by 2. All right, so dividing both sides by 2 leaves you with x is equal to 32,768. All right, now when you check, what you're really doing is just making sure that if it is a fourth root, right, when I plug this value in and I multiply by 2, you really just want to make sure that it's going to give you an even, a positive value. Because it's a fourth root, you don't want a negative underneath. All right, because then you're working with imaginary numbers, which is not part of this lesson. We're doing real solutions. So when I plug the 32,768 in and I multiply by 2, I am going to have a positive value, which I'll be able to take the fourth root of. So that's really all you need to do as far as your check is concerned. All right, let's move on to the next one. Number 5. So my radical is on the right-hand side this time, which it's already isolated. Nothing is outside of the radical on that right-hand side. So I move into squaring both sides of the equation. Now this one's a little bit different than the last. The square root does cancel with the square, but notice I have a binomial squared. So you have to FOIL. Don't just square the x and square the 7. You're going to be missing your middle term. So you have to write it out as x minus 7 times x minus 7 is equal to, and again, the square root and the square cancel, so you're left with x minus 5. When I FOIL over here, I'm going to have x squared minus 7x plus 49 is equal to x minus 5. Combining like terms, I have x squared minus 14x plus 49 equals x minus 5. Now, I know that this is quadratic, right? Because there's an x squared term and it's not going to be eliminated. It's not like I have an x squared on the other side that, we'll subtract and eliminate. So since it's quadratic, I'm going to set it equal to 0, try to factor. If I can't factor, I'll have to do quadratic formula. All right, so I'm going to subtract an x from both sides and at the same time add a 5 to both sides just so I can get a 0 on this side, the right-hand side of the equation. So I'm left with x squared minus 15x plus 54 equals 0. From here, I try to factor. I'm trying to come up with two numbers that multiply to a positive 54 and add to a negative 15. So that's going to be a negative 9 and a negative 6. I set each factor equal to 0, so x minus 9 equals 0, x minus 6 equals 0, and I solve for x. So I have x is equal to 9 and x is equal to 6. All right, I have to go back to the original problem and double check to make sure it makes sense and works. All right, so for this problem, I am going to go through and make sure. So if I plug in a 9 minus 5, all right, that's going to give me 4. Square root of 4, that's going to be a 2 on that side. When I plug in a 9 over here, 9 minus 7, all right, 9 minus 7 is going to give you a 2 as well. So 9 works. That does work. Now I have to plug in 6 to make sure that 6 works, all right? 6 minus 5, that's going to give you 1. Square root of 1 is 1. Okay, typically, like I said, you're really just trying to make sure that it's positive underneath there, but there is an x on the other side, so let's make sure when I plug it in, nothing weird happens. So 6 minus 7 would be over here, which is a negative 1. Well, negative 1 does not equal positive 1. So 6 is an extraneous solution. It's a false solution. It does not work. So the only answer here is 9. So again, this is why it's important to check your answers in this lesson. All right, moving on to number 7. So number 7, I have the radical on the left-hand side. I have to isolate by dividing both sides by 4 to start. So I have the square root of x plus 1 is equal to x plus 1 divided by 4. Now I have to square both sides. All right, so I'm going to have x plus 1 is equal to x plus 1 over 4 times x plus 1 over 4. All right, so I'm going to have x plus 1 equals. Now, I'm going to rewrite this just to make it a little easier as 1/4 x plus 1/4 and 1/4 x plus 1/4. Okay, so instead of being divided by 4, just turn it into 1/4. All right, I think it's just easier to FOIL that way. So when you FOIL, the first two terms multiply to 1/16 x squared. All right, the outer terms multiply to a 1/16 x. The inner two terms multiply to a 1/16 x. And the last two terms multiply to a 1/16. All right, from there, combining like terms, I have x plus 1 is equal to 1/16 x squared. And then I have a plus. It would be 2/16, which is 1/8 if you want to simplify. So 2/16, 1/8. That's what I meant to write. 1/8 x, and then plus 1/16. Again, this is quadratic, so I want to set it equal to 0. So I want to subtract an x and subtract a 1, both at the same time. So subtracting an x is the same thing as subtracting an 8/8x, right? Because 8/8 is just a 1. Minus a 1 or minus a 16/16, just so I have common denominators. So I have 0 is equal to 1/16 x squared. I'm going to have negative 7/8 x minus 15/16. All right, now I don't want to have to factor that because that looks pretty crazy to have to factor. I'm going to rewrite it up here. So what I'm going to do is multiply through by an LCD to eliminate the fractions, which will make it easier to multiply. So let me just write it down up here. So since the denominators are 16, 8, and 16, I'm going to multiply everything through by a 16. 1 second. Sorry, my dog was eating food off the counter, so I had to yell. All right, so I'm going to multiply everything through by a 16 to eliminate the fractions. So that leaves you a 0 equals 1x squared minus, because the 16s cancel there. 8 goes into 8 once, 8 goes into 16 2 times, so you're multiplying 2 times 7 to get 14x. All right, 16 goes into 16 once and once, so you're left with minus 15. Okay. If that was confusing to you, just multiply all the numerators by 16 and then simplify the fractions, and this is what you'll be left with. All right, now factoring two numbers that multiply to a 15 and add to a negative 14. So you're going to have a 15 and a 1, a negative 15 and a positive 1. Set each of those factors equal to 0. So x minus 15 equals 0. X plus 1 equals 0, and you're left with x is equal to positive 15 and x is equal to negative 1. We do want to double check to make sure both of those do work when plugged in. Let me just kind of erase all this so we can see the answers. So again, it's x equals 15 is one answer if it works, and x equals negative 1. All right, so plugging in, make sure you plug into both sides. If I plug in 15, 15 plus 1 is 16. Square root of 16 is 4. 4 times 4, that'll multiply to a 16. Plug in a 15 over here. 15 plus 1 equals 16. So I get 16 equals 16. That one works. If you need to write the checks down and can't do this all in your head, that's fine as well. Okay, plug in a negative 1. Negative 1 plus 1, that's 0. Square root of 0 is 0. 0 times 4 is 0. Over here, negative 1 plus 1 is 0. So you'd have a 0 on both sides. That one works as well. Oops, sorry, didn't mean to delete that so quickly. So the two answers are 15 and negative 1. All right. The next one of this type, number 9. Again, isolate the radical as much as you can to start. So subtract 2 from both sides. You have negative 4th root of 2x minus 6 is equal to 12. Divide everything by a negative. So I have the 4th root of 2x minus 6 is equal to negative 12. It's a 4th root, so to get rid of that radical, I have to raise both sides to the 4th power. So I'm going to have 2x minus 6 is equal to negative 12 raised to the fourth is going to actually, whoop, back up. I'm moving too quickly. I need to think about this for a second. Whoop, 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 whoop. Remember what I said? We need to be thoughtful as I'm trying to rush to get through this last problem. All right, so let me write what I had again. So fourth root of 2x minus 6 is equal to a negative 12, okay? So think about this for a second. All right, can you have a fourth root that's equal to a negative 12? Can you have a fourth root that's equal to a negative value? All right, so I'm going to say think about this as we are. Think about this. Okay, so as you're working through these problems, as I was kind of doing, I was just in a rhythm and I was going. You have to be thoughtful about each step and what it says. You can't have a fourth root equal to a negative value. Again, we're not working with imaginaries here. We're not having i's as part of our answers. We're in the real number system. You can't have a fourth root that is negative, okay? So you're going to say here, no real solution. All right, to be careful about those. All right, let's move on. We have a few more on the next page. All right, solve the equation, check your solutions. Okay, so for these fractional exponents, you're going to raise both sides to the reciprocal power. Okay, so first we're going to isolate as much as we can the variable, and then I'll explain what I just said in more detail. All right, so to isolate the variable, we're going to first multiply both sides by 2. So I have x to the 5 halves equals 32. Okay. Now, in order to get x by itself, we want x to have an exponent of 1. Right now, it has an exponent of 5 over 2. But look at this. Think about it. If I raise both sides to the reciprocal power, so 5 over 2, or 2 over 5, excuse me, 32 to the 2 over 5. All right, 5 over 2 times 2 over 5, that simplifies down to just a 1. So I have x to the first, or just x, is equal to 32 raised to the 2/5. Okay, so with those fractional exponents, all right, what you're going to do is multiply both, or not multiply, excuse me, raise both sides of the equation to the reciprocal exponent, because then that'll eliminate the exponent on the variable. You're just left with an exponent of 1, which is the goal. All right, so now I might want to rewrite it as the fifth root of 32 to see if it can be simplified and then squared. Okay, the fifth root of 32 is a 2. So I have 2 squared, and then 2 squared is simply a 4. Okay. And again, check these solutions. So do a quick mental check and plug it in. All right. This one does work. We're going to kind of, I'll show you real fast. I'll go through the check. So if I plug in a 4, I have 1/2, and then 4 raised to the 5 over 2 equals 16. Remember, 5 over 2 is really the same thing as the square root of 4 raised to the 5th. The square root of 4 is 2, so now I have 1/2, 2 to the 5th. 2 to the 5th is 32, so 1/2 times 32, and 1/2 of 32 is 16. So it does work. Okay, I just wanted to remind you how to evaluate those fractional exponents. All right. All right, and then the last two that I'm going to do are solving inequalities. And for these, just a quick little note before I get started. I'm going to say consider rejectable answers at the end. And I'll explain that as we do the first problem. Okay. All right, I should have moved my page up before starting. Okay, I'm going to leave that little note down there just so I don't erase it right now. Okay, so for 13, we're first going to get started the same way. Isolate the radical as much as possible. Keep in mind you are working with inequality, so if you multiply or divide by negative, flip that inequality symbol. So subtracting 3 from both sides leaves me with a -4. Then I'm going to divide both sides by a -4. And remember what I said, when you divide by a negative, don't forget to flip that inequality symbol. All right, so right now I have the square root of x minus 1 is less than or equal to 1. Then, just like we've been doing, square both sides. All right, so now I have square root and square cancel. X minus 1 is less than or equal to 1. All right, and finally add the 1 to both sides. So x is less than or equal to 2. Okay, so before you say, okay, I'm done, let's think about the original problem to make sure that that works and to make sure there's no rejectable solutions. Numbers won't work. Okay, so let me erase this for a second. So right now my answer is that x is less than or equal to 2. So if the answer is x is less than or equal to 2, that means I should be able to plug 2 in here, right? So if I plug a 2 in, 2 minus 1 is 1. The square root of 1 is 1. Okay, that I can do that. I could plug in a 1. 1 minus 1 is 0. The square root of 0 is 0. 0 times negative 4 is 0. And then I'd be left with 3 is greater than or equal to negative 1. That works. If x is less than 2, just another example of what I could plug in, I could plug in a 0. All right, 0 minus 1 is a negative 1. The square root of negative 1, well, as I've been saying, we're not working with imaginary numbers right now, only the real number system. So I can't plug in 0 because that's going to leave me with a negative under square root. You can't have a negative under the square root in the real number system. All right, so the smallest number that I can plug in is the number that will make the radical a 0 underneath. Okay, so again, if I plug in a 1, 1 minus 1 is 0. The square root of 0 is 0. That works, okay? But I can't have anything less than 0 under the radical. So since I can't have anything less than 0 under the radical, and the value 1 is what makes it a 0, that means that x has to be greater than or equal to 1. All right, so x is less than or equal to 2. That's the solution I got by solving. But then I have to think about rejectable solutions. Remember what I said here, consider rejectable answers at the end. Since you can't have anything less than 1 underneath because it won't work, then I have to make that limitation. I have to put that restriction on there. Okay, so that's the answer there. All right, number 15 I'll do as well. Let me erase everything I have so far. Okay, so I'm going to add 39 to both sides. So I have 2 times the square root of 3 over 4x is less than or equal to 14. Then I'm going to divide both sides by 2. So I have the square root of 3 over 4x is less than or equal to 7. Then I'm going to square both sides. So now I have 3 over 4x is less than, hold on 1 second. I guess I could move this down real fast. Maybe I can. Oh, there we go. Give myself a little more room. All right. Less than or equal to 49. Then I'm going to multiply both sides by the reciprocal of the fraction. So 4 over 3. So I have x is less than or equal to, and I have it as a mixed number on my page, 65 1/3. Okay. Again, I know I always stress that we don't like mixed numbers, which is true. We do typically want all your answers in proper fraction form. But again, if you're thinking about like number lines and graphing points and, try to visualize this on the number line, oftentimes it makes more sense to think of it in mixed number form. But you don't have to. You can leave it as an improper fraction if you want. Okay. So again, there may be a restriction here. All right. So let me go back to the original problem and think. So this is my answer so far, that x can be anything less than or equal to 65 1/3. All right. Well, remember what I said over here. The smallest number that you can have, the smallest value you can have under the radical is a 0. All right. Over on this situation, when I plugged in a 1, that's what made it a 0. What number here, when plugged in for x, would make it a 0? If I plug in a 1, it's going to be a 3/4. But if I plug in a 0, that's going to give me a 0 underneath. So the smallest value that x can be is 0. X has to be greater than or equal to 0. Because if I plug in anything less than 0, I'm going to end up with a negative under the radical. All right, so that is the answer there. All right, guys, so that is day 1 of lesson 5.4. Remember what I said? I'm breaking this into 2 days. So I'm going to go back through with you guys for the next lesson, working on the evens to hopefully make sure you fully understand the concepts of this lesson. All right, I will see you for the next lesson. Bye.